Hello students, in the previous video of trigonometric functions, we had seen the units of measurement, degree and radian. In this video, we are going to study all the important formulae for trigonometric functions and the examples based on them. This is a very important topic, so watch the video till the end. Now some basic concepts. We extend the definition of trigonometric ratios to any angle in terms of radian measure and study them as trigonometric functions. That means suppose you have a unit circle with the center at origin. Unit circle means radius is 1 unit. Let P, which has coordinates AB, be any point on the circle with angle AOP is equal to x radian. Please see the diagram. Angle AOP is x radian. What does that mean? The length of arc AP is x. Now we defined cos x is equal to A coordinate of point P and sin x is equal to B. Thus for every point on the unit circle we can have cos square x plus sin square is equal to 1. Why? Because you can see that triangle PMO is a right angle triangle with right angle at M, which gives us a square plus b square is equal to 1. That means cos square plus sin square will be equal to 1 for any such point. All angles which are integral multiples of pi by 2 are called quadrantal angles. Remember, in the unit circle we are having 0 to pi by 2, pi by 2 to pi, pi to 3 pi by 2 and 3 pi by 2 to 2 pi. This is how you have the 4 quadrants. The coordinates of the points will be as given. A point will have coordinate 1 0, B will have 0 1, C minus 1 0 and D 0 minus 1. Now some things which you need to note are sine of 2n pi plus x is equal to sin x for any integer n. That means n can take any negative 0 or positive values. For example, if n is 0, sin x is sin x. If n is 1, sine of 2 pi plus x. That means once the whole revolution is completed, again if you start it, you will get the same angles. So sine of 2 pi plus x will also be sin x, and suppose n is minus 1, sine of minus 2 pi plus x will also be sin x. That means after one revolution from 0 to 2 pi, when again it is repeated, you get the same value of sine. Similarly for cos, cos of 2n pi plus x will be equal to cos x for any integer n. Now suppose sin x is 0. What does this imply? X will be n into pi where n is an integer. Why? Because you know that suppose n is 0, then x is 0. Suppose if n is 1, x is pi, and n is minus 1, x is minus pi. So you know that in the unit circle for 0, pi, minus pi, the value of sin x is 0. Why? Because the y coordinate is sin x and y coordinate is 0. Cos x will be 0 when x is equal to 2n plus 1 pi by 2, where again n is an integer. So if it is any multiple of pi by 2, the value of cos will be 0, because you know that the coordinates will have the x coordinate as 0. That means cos x will be 0. For pi by 2, 3 pi by 2, any multiple of pi by 2, cos x will be equal to 0. Cosec is 1 upon sine. So cosec x is 1 upon sine x provided x is not equal to n pi. Why? Because if x is equal to n pi, sine x will be 0. So 1 upon 0 is not defined. Similarly, sec x is 1 upon cos x. So your x should not be equal to 2n plus 1 pi by 2. Tan x is sin x by cos x. Again over here 1 upon 0 or anything upon 0 is not defined. So cos x should not be equal to 0, means x should not be equal to 2n plus 1 pi by 2. For cot x, x should not be equal to n pi where n is any integer. Now which are the three basic identities? Sin square plus cos square is equal to 1. From that, suppose you divide this equality by cos square x, you will be getting 1 plus tan square is equal to sec square x. And if you divide it by sin square x, you will get 1 plus cot square is equal to cosec square x. These are the three basic identities. Now these are the values of trigonometric functions at some important angles. First of all, the angles are given in degrees and then in radians. You are given all the values of sine, cos, tan, cot, cosec and sec. So if you remember sine and cos, other values will follow. There is a trick to remember this. I have also shown it in the one of the shorts for trigonometric functions. I will give the link in the description box. The easy way is, first of all you write sine and cos and then you write 0, 1 by 4, half, 3 by 4 and 1. Just take the square root of it. So you will get 0, 1 by 4 square root is half, 1 by 2 square root is 1 upon root 2, 3 by 4 square root is root 3 by 2 and 1 square root is 1. So this is how you get the values of sine. Reverse it, you will get the values of cos. This is a very easy trick, so you can remember all these values. Now you need to remember this, the sign of trigonometric functions in the 4 different quadrants. So if you have the unit circle I have shown over here, you have the 4 quadrants, first, second, third and fourth, and the value of all the trigonometric functions for it. Very easy way to remember is, it is all STC, or you can say ASTC. Just remember ASTC. That means in the first quadrant all are positive. In the second quadrant S means only sine is positive. But if sine is positive, 1 upon sine means cosec will also be positive. In the third quadrant T means tan is positive, so cot, its reverse will also be positive. In the fourth quadrant C means cos is positive, so 1 upon cos, which is sec, is also positive. All ASTC. Now this chart gives you the behavior of trigonometric functions in the 4 quadrants. You don't need to memorize this, but you can understand it definitely. Like for example, in the first quadrant you can see that first quadrant means from 1 0 to 0 1. That means sine increases from 0 to 1. How do you have the coordinates? Cosec sin x. So from 1 0 to 0 1 means from sin x goes from 0 to 1. Similarly in the first quadrant cos x decreases from 1 to 0, and similarly other functions follow. This is how in all the 4 quadrants you can just see the behavior of the important trigonometric functions. Now these are the graphs of the 6 important trigonometric functions. We have seen the values of the function at different angles. So based on that, if you draw the graph, it will be looking like this. Specifically in multiple choice questions, you can be asked to identify the graphs of the trigonometric functions. Like for example sin x, the graph is given from minus 2 pi to 2 pi. So you know that at minus 2 pi or at 0 or at 2 pi it is 0. Similarly it is 1 at which points? Pi by 2 and minus 3 pi by 2. Minus means you go in the clockwise direction, correct? Similarly, when is it minus 1? It is minus 1 at minus pi by 2 and at 3 pi by 2. Similarly, the other graphs can also be drawn. Let us see some examples based on what we have done. Example 1. Find the values of other 5 trigonometric functions if in the first case it is given that cos x is minus half and x lies in the third quadrant. This is given to us. Now since cos x is minus half, sec x is 1 upon cos x, which will be minus 2. Sin square plus cos square is equal to 1. From this identity we get sin square is equal to 1 minus cos square, which is 3 by 4. That means sin can be plus or minus root 3 by 2. But since x lies in the third quadrant sin x is negative. Just remember ASTC. That means in the third quadrant only tan is positive. So obviously sin will be negative. So sin x will be minus root 3 by 2. Cosec x 1 upon sin x, which is minus 2 by root 3. Tan x is sin x upon cos x, which is root 3. And cot x can be cos x upon sin x or 1 upon tan x, which is 1 upon root 3. So we have got all the values of trigonometric functions in this example. Second example, tan x is equal to minus 5 by 12 and x lies in the second quadrant. This is given to us. We have to find other trigonometric functions. Now here, since tan is given, we will use the identity 1 plus tan square is equal to sec square x. So which will give us sec x is equal to First of all, sec square x is equal to 169 by 144 and you have to take the square root. So square root can be positive or negative, but over here it is given x lies in the second quadrant. You know, in the second quadrant, ASTC means in the second quadrant only sign is positive. So sec x is 1 upon cos x. So sec x will be negative. So sec x will be minus 13 by 12. Square root of 169 by 144, but we have to take minus. So sec x is equal to minus 13 by 12. Cos x is 1 upon sec x, so minus 12 by 13. Sin x can be written as 10x into cos x. So that will give us 5 by 13. Cosec x 1 upon sin, which is 13 by 5. Cot x is 1 upon 10, which is minus 12 by 5. So given 10x, we have found the values of all the other 5 trigonometric functions. Example 2. Find the values of the following trigonometric functions. First is sine of 765 degree. 765 degree we write as 2 into 360 degree plus 45 degree. Why? Because you know that in the whole circle after 360 degree, or you can say after 2 pi, the values are repeated. So sine of 765 degree is nothing but sine of 45 degree. So that is equal to 1 upon root 2 from the table which we have just seen. Cosec of minus 1410 degree. Again, as I told you, first try to make it in the multiple of 360 degree. So that can be written as minus 3 into 360 degree plus 30 degree. So again, just take out the multiple of 360 degree or 2 pi. And then what you get is as cosec of 30 degree. What is cosec 30 degree? We know it is 2. Cot of minus 15 pi by 4. So the angle can be given in radian or in degree. Here it is given in radian. So in radian, you again try to take out the multiples of 2 pi. So minus 15 pi by 4 can be written as minus 4 pi plus pi by 4. So that is nothing but cot of pi by 4. You know cot of pi by 4 is 1. Now comes the important set of formulas which you need to remember for the examples. First thing is sine of minus x is equal to minus sin x and cos of minus x is cos x. Why is it so? Because sine of minus x basically you can write as 2 pi minus x. That means in the fourth quadrant. But in the fourth quadrant you know that ASTC means only cos is positive. So sine of minus x will be minus sin x, but cos of minus x will be cos x. Second set of formula, cos of x plus y is cos x cos y minus sin x sin y. And similarly cos of x minus y is cos x cos y plus sin x sin y. Sin of x plus y is sin x cos y plus cos x sin y. And sin of x minus y is sin x cos y minus cos x sin y. Right? Third set of formulae. Now this you will understand it. Cos of pi by 2 minus x. Pi by 2 minus x, that means it is in the first quadrant. So obviously everything is positive. And when you take pi by 2, the function will change. If you take pi, the function will not change. Remember this. So cos of pi by 2 minus x will be sin x. Sin of pi by 2 minus x will similarly be cos x. Now if you take cos of pi by 2 plus x, pi by 2 plus x means in the second quadrant. So in the second quadrant you have only sign positive. So if you are taking cos of pi by 2 plus x will be minus sin x. But if you take sine of pi by 2 plus x, it will be cos x because sine is positive in the second quadrant. Similarly cos of pi minus x. Again pi minus x is in the second quadrant. So in the second quadrant cos is negative. So cos of pi minus x is minus cos x. But sine of pi minus x is sin x because sine is positive in the second quadrant. Cos of pi plus x means it will be in the third quadrant. So pi plus x is minus cos x because in the third quadrant sine and cos both are negative. Again sine of pi plus x will be minus sin x. Cos of 2 pi minus x means in the fourth quadrant. In the fourth quadrant only cos is positive. So cos of 2 pi minus x will be cos x and sine of 2 pi minus x will be minus sin x. So two things in this set of formula, you don't need to memorize it, but just remember is If you are taking pi by 2, the function will change, and if you are taking pi, it will not change, and the sign will depend on ASTC, which quadrant it belongs to. So this set of formulas you need to remember. Now next set of formula. If none of the angles x, y and x plus or minus y is an odd multiple of pi by 2, then why it should not be a multiple of pi by 2? Because tan is sine upon cos, and at pi by 2 cos will be 0. So it is not defined. So now tan of x plus y is given by tan x plus tan y upon 1 minus tan x into tan y. And similarly tan of x minus y is tan x minus tan y upon 1 plus tan x into tan y. Again, if none of the angles xy or x plus or minus y is a multiple of pi, then cot of x plus y is cot x cot y minus 1 upon cot y plus cot x. And cot of x minus y is cot x cot y plus 1 upon cot y minus cot x. So this is a set of formula for tan, summation of angles and subtraction of angles for tan and cot. Next set of formulae is for the angles when you take twice the angles. So cos 2x is cos square minus sine square, or you can cos square minus sine square. That means if you write sine square in terms of cos square, you will be getting it as 2 cos square minus 1. And if you write cos square minus sine square in terms of sine square, then cos square is 1 minus sine square. So ultimately it will be 1 minus 2 sine square. So what you need to remember is cos of 2x is cos square x minus sine square x, or 2 cos square x minus 1, or 1 minus 2 sine square x, or 1 minus tan square x upon 1 plus tan square x. Similarly, sin 2x is 2 sin x cos x, or 2 tan x upon 1 plus tan square x. Tan 2x is 2 tan x upon 1 minus tan square x. Sin 3x is 3 sin x minus 4 sin cube x, and cos 3x is 4 cos cube x minus 3 cos x. Similarly, tan 3x is 3 tan x minus tan cube x upon 1 minus 3 tan square x. Now the most important set of formulae. Cos x plus cos y is equal to 2 cos x plus y by 2 cos x minus y by 2. So this is in the form of summation and subtraction of angles. Cos x minus cos x is minus 2 sin x plus y by 2 sin x minus y by 2. Sin x plus sin y is 2 sin x plus y by 2 cos x minus y by 2. And sin x minus sin y is 2 cos x plus y by 2 sin x minus y by 2. Other ways, other four formulas. 2 cos x cos y is equal to cos x plus y plus cos x minus y. Minus 2 sin x sin y is equal to cos x plus y minus cos x minus y. 2 sin x cos y is equal to sin x plus y plus sin x minus y. 2 cos x sin y is equal to sin x plus y minus sin x minus y. Generally, how these formulas are remembered is C plus C is equal to 2cc, and C minus C is equal to minus 2ss. S plus S is 2sc, and S minus S is 2cs. So please remember this set of formulas. Now we will be solving the examples based on these formulae. Example 3, first case. Prove that 2 sin square pi by 6 plus cosec square 7 pi by 6 cos square pi by 3 is equal to 3 by 2. So first of all, we write the left hand side what is given. Now sin pi by 6, you know it is half, so 2 into half square, plus cosec square 7 pi by 6. Again, as I am telling you, generally try to convert the angles 7 pi by 6 as pi plus pi by 6. Into again cos pi by 3 is half, so half square. Now cosec pi plus pi by 6. Cosec means 1 upon sine. So pi plus pi by 6 means it will be in the third quadrant. So in the third quadrant, ASTC only 10 is positive. So cosec will be negative. So cosec of pi plus pi by 6 is minus cosec of pi by 6 and the whole square of that. Okay, anyways you have square over here, but this is for understanding. So now cosec pi by 6 is 2. So you have minus 2 whole square. So the right hand side we get it as 3 by 2. The second case in example 3, prove that 2 sine square 3 pi by 4 plus 2 cos square pi by 4 plus 2 sec square pi by 3 is equal to 10. First we write the left hand side. This is equal to, now 3 pi by 4. Can it be written as pi minus pi by 4? Yes. So pi minus pi by 4. Now sine of pi minus pi by 4 will be equal to, we know that if we have pi, then the trigonometric function will not change. If it is pi by 2, it will be the opposite function. So sine of pi minus pi by 4 is sine pi by 4, and since it is in the second quadrant, so sine is positive. So sine of pi minus pi by 4 is sine pi by 4 and the square of that. So 2 into 1 upon root 2 whole square plus 1 plus 8, putting the values, we get the right hand side as 10. Now example 4. Cos of pi by 4 minus x into cos of pi by 4 minus y minus sine of pi by 4 minus x into sine of pi by 4 minus y is equal to sine of x plus y. Now we need to prove this, and when we see the left hand side, cos into cos and sine into sine is given. So we will use the given set of formula. For that we multiply the left hand side by 2. So 2 into left hand side is equal to 2 into the whole left hand side which is given. Now we try to simplify it. 2 cos into cos is cos of x plus y, means the cos of sum of the angles plus cos of subtraction of the angles. So in the first case, cos of sum of the angles is pi by 4 minus x plus pi by 4 minus y, and when we take the difference of the angle, it is pi by 4 minus x minus pi by 4 minus y. Barabar? Then in the next step, for 2 sine, that is equal to cos x plus y minus cos of x minus y, but with a negative sign. So minus into bracket cos of sum of the angles, again over here is pi by 4 minus x plus pi by 4 minus y, and difference is pi by 4 minus x minus pi by 4 minus y. When you put the signs, please take care. So now it simplifies into cos of pi by 4 plus pi by 4 means pi by 2 minus x plus y plus cos of y minus x. And for the second term, minus minus will become plus. So cos into again pi by 2 minus x plus y and minus cos of y minus x. So when you simplify this, now again remember, when it is pi by 2, the function changes. When it is pi, it doesn't change. So cos of pi by 2 minus x plus y will become sine of x plus y. Correct? And since pi by 2 minus x plus y means in the first quadrant everything is positive. So cos will be changed to sine x plus y. Second term is cos of y minus x, which gets cancelled out with minus cos of y minus x. The third term, again cos of pi by 2 minus x plus y will become sine of x plus y. So we have 2 times sine of x plus y, which is 2 into right hand side. So 2 into left hand side is equal to 2 into right hand side, and hence left hand side and right hand side are equal. Now example 5. Prove that cos square 2x minus cos square 6x is equal to sine 4x into sine 8x. Now we simplify the left hand side. We know a square minus b square is a minus b into a plus b. So left hand side will be cos 2x minus cos 6x into cos 2x plus cos 6x. Now cos minus cos is minus 2 sine sine. So cos 2x minus cos 6x is minus 2 sine of x plus y by 2, means 2x plus 6x by 2, that is equal to 4x. And x minus y by 2 angle will be 2x minus 6x by 2 minus 4x by 2 or minus 2x. So this is the first term. Similarly, cos plus cos is 2 cos cos. So cos 2x plus cos 6x is 2 cos 2x plus 6x by 2 is 4x angle, and again 2x minus 6x by 2 is minus 2x. Now we know that sine of minus x is minus sine x and cos of minus x is cos x. This is the first formula which we have seen. So sine of minus 2x will become minus sine 2x and cos of minus 2x will be cos of 2x. When we simplify this, we get as 2 sin 4x sin 2x, 2 cos 4x cos 2x. Now we group the terms having the same angle. So 2 sin 4x cos 4x into 2 sin 2x cos 2x. Now we have another important formula for 2 times the angle. So sin 2x is 2 sin x cos x. So here just the opposite, 2 sin x cos x. 2 sin 4x cos 4x is given. Then this will be equal to double the angle, which is sin 8x. And similarly 2 sin 2x cos 2x will become sin 4x. This is equal to the right hand side. Example 6. Cot 4x into sin 5x plus sin 3x. Prove that this is equal to cot x into sin 5x minus sin 3x. Now, first of all, let us simplify the left hand side. Left hand side is equal to cos 4x upon sin 4x. First cot is cos upon sin. So this is equal to cos 4x upon sin 4x. Now into bracket we have sin 5x plus sin 3x. S plus S is 2SC. So this is equal to 2 sin 5x plus 3x by 2. That angle will become 4x, and 5x minus 3x by 2. That angle will become x. So sin 5x plus sin 3x is equal to 2 sin 4x cos x. So now over here sin 4x will get cancelled. So left hand side is simplified as 2 cos 4x into cos x. Now what we do is, since from this we might not get directly the right hand side, it might be more difficult. So we try to simplify the right hand side. Right hand side is cot x into sin 5x into sin 3x. So cot x we write as cos x upon sin x. Again in the bracket we have s minus s, which is equal to 2cs. So sin 5x minus sin 3x is 2 cos 5x plus 3 by 2. That means the angle is 4x, and 5x minus 3x by 2. That means the angle will become x. Again this simplifies to 2 cos 4x into cos x. Now since left hand side and right hand side are simplified into the same thing, we can say left hand side is equal to right hand side. The same example can be proved in other ways also. Example 7. All examples will be of different type and you will have to use different set of formulae for each of them. Tan 4x is equal to 4 tan x into 1 minus tan square x upon 1 minus 6 tan square x plus 10 raised to 4x. Now we try to simplify the left hand side. Since tan 4x is given, we can write 4x as 2x plus 2x. See, looking at the left hand side and right hand side, you will get an idea that from 4x you want the angle x. So first thing is, though, 4x you will write as tan of 2x plus 2x. Now we have a formula, tan 2x is equal to 2 tan x upon 1 minus tan square x. Now here the angle is x. Instead of x, if we take the angle 2x, then we can write this as 2 tan 2x upon 1 minus tan square 2x. So in the formula which is given on the right hand side, we are just replacing our angle x by 2x. So again we now simplify tan 2x. So again tan 2x can be written as 2 tan x upon 1 minus tan square x. Now the denominator, take the LCM and try to simplify. So the second term you have 1 upon 2 upon 3 upon 4 term. So the second term and fourth term, second term is 1 minus tan square x and the last term is 1 minus tan square x whole square. So one of them will get cancelled. So in the numerator you will have 4 tan x into 1 minus tan square x. And in the denominator, after taking the LCM, you will have 1 minus tan square x whole square minus 2 tan x whole square is 4 tan square x. So now the denominator we try to simplify. It is 1 minus 2 tan square x plus 10 raised to 4x minus 4 tan square x. This simplifies into 1 minus 6 tan square x plus 10 raised to 4x. So ultimately we get the right hand side. Example 8. Prove that cos 4x is equal to 1 minus 8 sin square x cos square x. Now looking at the example, you will have to decide which formula you have to use. So now left hand side is cos 4x. So just like the previous example, 4x you can write as 2 into 2x. So now we again have a formula. Cos of 2 times the angle is 1 minus 2 sine square A. So here you can write it as 1 minus 2 sine square 2x. Here instead of angle A you have angle 2x. So 1 minus 2 sine square 2x. Again you have sine 2x, sine 2a is equal to 2 sine a cos a. So sine 2x can be written as 2 sine x cos x. So left hand side will become 1 minus 2 into 2 sine x cos x whole square. So that is 1 minus 8 sine square x cos square x, which is the right hand side. Now example 10. This is a different kind of example. If tan x is equal to 3 by 4, x lies between pi and 3 pi by 2, find sine x by 2, cos x by 2 and tan x by 2. We have done a similar type of example, but here the angle which we have to find out is for x by 2. So first thing is we convert our x to x by 2 by dividing by 2. So pi by 2 less than x by 2 less than 3 pi by 4. 3 pi by 4 means less than pi. So our angle x by 2 lies between pi by 2 and some angle less than pi. So obviously in the second quadrant. So our angle x by 2 lies in the second quadrant, and keep in mind that in the second quadrant only sign is positive. Now we have tan identity. Tan 2x is equal to 2 tan x upon 1 minus tan square x. Here instead of x, let us take angle x by 2. So we get tan x is equal to 2 tan x by 2 upon 1 minus tan square x by 2. And tan x is given to be 3 by 4. So now just solve this equation. You have an equation of the kind 3 tan square x by 2 plus 8 tan x by 2 minus 3 equal to 0. This is a quadratic equation of the type 3a square plus 8a minus 3 equal to 0. You know how to solve this? Simplified, it will be 3a square plus 9a minus a minus 3 equal to 0. So the factors will be minus 3 and a by 2. Sorry, the roots will be minus 3 and 1 by 3. Now the roots over here are minus 3 and 1 by 3, and what is the variable? Our variable is tan x by 2. So tan x by 2 is 1 by 3 or tan x by 2 is minus 3. But in the second quadrant we know that everything except sign is negative. So tan is negative. So tan x by 2 is minus 3. We choose minus 3 because tan is negative. Now we have sec square x is equal to 1 plus tan square x, which gives us sec square x by 2 is equal to 10. So sec x by 2 is equal to plus or minus root 10. But again in the second quadrant you have cos is negative and so sec is negative. So sec x by 2 is equal to minus root 10. So cos x by 2 is minus 1 upon root 10. Now sine we can write as tan into cos. So sine x by 2 is 3 upon root 10. You can check over here that we have got sine positive. Why? Because our angle lies in the second quadrant. Now the same example can also be solved in a different way by first converting tan function to sec function and then using the identity cos 2x is equal to 1 minus 2 sine square x. We will get the same values of the angles. Example 10. Prove that 2 cos pi by 13 cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13 is equal to 0. Now see over here, in the first term you have 2 cos cos. So we can use the identity 2 cos cos is equal to cos plus cos. So left hand side, the first term 2 cos pi by 13 cos 9 pi by 13, it can be simplified as cos of sum of the angles, which is pi by 13 plus 9 pi by 13 or 10 pi by 13. Second term is difference of angle pi by 13 minus 9 pi by 13, which is minus 8 pi by 13. Other two terms we just now keep it as it is. Now you know cos of minus of angle is cos of that angle, means cos of minus x is always cos x. So cos of minus 8 pi by 13 is cos of 8 pi by 13. So now you have cos 10 pi by 13 plus cos 8 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13. Now you know 10 pi by 13. I can write it as pi minus 3 pi by 13. And 8 pi by 13 can be written as pi minus 5 pi by 13. Now since you have cos of pi minus 3 pi by 13, we know whenever it is pi, the function will not change. But cos will remain to cos. But pi minus 3 pi by 13 means in the second quadrant. The second quadrant cos is negative. So cos of pi minus 3 pi by 13 is minus of cos of 3 pi by 13. And similarly cos of pi minus 5 pi by 13 is minus cos 5 pi by 13. Hence the terms will get cancelled and we get the right hand side as 0. Now some assignment examples. Please solve these examples. You will get a clear idea of the topic. First, prove that sin n plus 1 of x into sin n plus 2 of x plus cos of n plus 1 into x into cos of n plus 2 into x is equal to cos x. We have done a similar example. Second one, prove that sin square 6x minus sin square 4x is equal to sin 2x into sin 10x. Third, prove that sin x minus sin y upon cos x plus cos y is equal to tan of x minus y by 2. Fourth, prove that cos 6x is equal to 32 cos raised to 6x minus 48 cos raised to 4x plus 18 cos square x minus 1. Fifth one, prove that sin 3x plus sin x into sin x plus cos 3x minus cos x whole into cos x is equal to 0. You will have to use the identities which we have seen. In this video, we have seen all the important formulae and examples based on this. In the next video, we are going to see the important questions of this chapter which were asked in JEE. So keep watching. Do like and share the video and subscribe to the channel.